Then you may start.
Hindi makita inyong nang, ma'am.
Ansa?
Okay siya?
Yeah. I can see it. Yes, sige, continue.
Okay po. Wala po kasi si Abigail, ma'am, kasi na-asthma daw po siya. So, siya sana yung sa intro. So, good morning, everyone. We are Farm Group 3, and today we will be reporting the Laboratory Activity 11, which is entitled the Acid-Base Titration. So, pa-next ko. Okay, next.
Wala pa na next?
Wala pa. Ay, mahirapan ka mag-scroll, Kyle. Ako na lang siguro, or okay lang. So, ako na lang mag-screen share.
Ay, ito na lang. Sige, paday na.
Sige. So, the content of our activity is the objectives, materials, procedure, result, guide questions, and the conclusion. Okay, next. So, our objective for this activity is to complete the table of data and to determine the normality and molarity of NaHCO3. The second objective is to explain the use of methyl orange in the experiment. And the third one is to distinguish between equivalence point and endpoint, direct titration and back titration, and the primary standard and secondary standard. Next, please. So, in conducting this activity, the materials that was used are the following: sodium bicarbonate tablets weighing 325 milligrams, burette, methyl orange indicator, and mortar and pestle. Next, Kyle. So, ang next ata is si Janica.
So, good morning, everyone. In the procedure, first, we weigh 2 tablets and determine the weight per tablet. Each group will assay a tablet separately for content uniformity to be done in 2 trials. Second, powder each tablet finely in a mortar and transfer accurately into an Erlenmeyer flask. Add 20 ml of water to the mortar and dissolve or disperse the remaining particles. And lastly, transfer the washing into flask containing the ground tablet. Repeat the washing with the first portion in the flask and mix well. Then add methyl orange TS and titrate with 0.02 N sulfuric acid until a pinkish red color is produced. Next, please. So in the result, the weight per tablet in trial 1 is 0.35 grams, while in trial 2 is 0.36 grams. The volume of sulfuric acid used in trial 1 is 70.7 ml and in trial 2 is 67.9 ml. The normality of sulfuric acid in trial 1 and 2 is 0.02 N, and the normality of sodium bicarbonate in trial 1 and 2 is 0.07 N. And lastly, the molarity of sodium bicarbonate in trial 1 and 2 is 0.07 moles per liter.
For the solution, we have here for the trial 1 to get the normality of sodium bicarbonate. First, we need to get the weight of the sulfuric acid. So N equals weight over volume times MEQ weight. So we have 0.02 MEQ over ml equals times 0.049 grams per MEQ. So to get the MEQ weight, we have MEQ weight equals molecular weight over F times 1,000. So molecular weight ng sulfuric acid is 98 grams per mole. 98 grams from H, hydrogen, we have 2, sulfur, we have 1, and 0. Oxygen, we have 4 times 16 for the oxygen, then 32 for the sulfur, and 1 for the hydrogen. We have 2, 32, 64. Then we add is 98 grams per mole. So 98 grams per mole over 2 from the sulfuric acid. So it's acid. Then ang hydrogen niya is dalawa. So ang F is 2 times 1,000. We have MEQ weight equals 0.049 grams per MEQ. So since naana tayo mga digits, we can now proceed with the solution. So weight equals 0.02 MEQ per ml times 70.7 ml times 0.049 grams per MEQ. Cancel the MEQ and ml. So naiwan is grams. Then the weight of sulfuric acid is 0.069286 grams. So we can now proceed with the sodium bicarbonate. So for the sodium bicarbonate, we will use the weight from the sulfuric acid, then we will continue using the stoichiometry. So 0.069286 grams of sulfuric acid times its molecular weight, which is 98 grams H2SO4 I over the I, the times 2 moles of NaHCO3 from a balance equation over 1 mole H2SO4 times 84 grams NaHCO3 molecular weights ng sodium bicarbonate over 1 mole NaHCO3 para makancel, and maiwan is yung grams ng NaHCO3. So overall, we have 0.118776 grams NaHCO3. Next is to get the normality of the sodium bicarbonate. We have N equals weight over volume times MEQ weight. So 0.11876 grams over 20 ml times 0.084 MEQ weight. We have here the molecular weight of the sodium bicarbonate, 84 grams per mole over 1 from the NHCO3. So we have 1H times 1,000, 0.084 grams per MEQ. So 0.11876 grams over 20 ml times 0.084 grams per MEQ, we have 0.0707 MEQ per ml, or 0.079 normality. Next. And for the molarity of trial 1, we have here M times F equals N. So ang M times 1 H, then equals 0.07 EQ per liter. Then we have divide it both sides with 1 EQ per mole para makancel ang 1 EQ per mole. Then we have 0.07 EQ per liter divided by 1 EQ per mole. We have 0.07 mole per liter or 0.07 molarity. That's for trial 1.
So we have here for trial number 2. Ay, wait lang po, mama. Okay, sorry po. So we have here for trial number 2, the given is 20 ml and 67.9 ml of 0.02 normality of H2SO4. So to get the molarity, we need first to get the weight of the sulfuric acid. So N is equals to weight divided by volume times MEQ per weight. So since hindi pa given yung MEQ per weight, so we need to get it muna. So MEQ per weight is equals to molecular weight divided by the frequency times 1000. So the molecular weight of H2SO4 is equals to 98 grams per mole divided by 2 MEQ per mole times 1000 since meron tayong dalawang hydrogen. So the MEQ per weight is now equal to 0.049 grams per MEQ. So i-substitute na natin. So 0.02 MEQ per ml is equals to weight divided by 67.9 ml times 0.049 grams per MEQ. So now weight is equals to 0.02 MEQ per ml times 67.9 ml times 0.049 grams per MEQ. So cancel out the MEQ and then the ml. So ang natira so the answer is weight of sulfuric acid is equal to 0.066542 grams. So we have here the balanced equation, and now let's proceed to the next step. So the weight of sulfuric acid, which is equal to 0.066542 times 1 mole of H2SO4 over 98 grams of H2SO4 times 2 mole of NaHCO3, which came from the balanced equation, over 1 mole of H2SO4 times 84 grams of NaHCO3 over 1 mole of NaHCO3. So cancel out the grams of H2SO4, the mole of H2SO4, and then the mole of NaHCO3. So we have here the answer of 0.114072 grams of NaHCO3. So in order to get the molarity, have here weight is equal to volume times MEQ per weight. It is equal now to 0.114072 grams divided by 20 ml times MEQ per weight na 0.084 grams per MEQ. So canceled out the grams. We have here 0.0679 MEQ per ml or 0.07 normality. Next, Kyle. So for trial number 2 sa molarity ng ating sodium bicarbonate, we have here M times F is equals to N, wherein M here is the molarity, F is the frequency, and N is for the normality. So substitute, we have here M times 1 EQ per mole over 1 EQ per mole is equals to 0.07 EQ per liter over 1 EQ per mole. So we have here 0.07 mole per liter or 0.07 molar. And then for the guide question number 1, explain the use of methyl orange in the procedure. So the methyl orange is the indicator added in the solution. Its use is to give visible sign or change of color when the endpoint is reached.
Good morning. So, sa number 2 na guide question is A, equivalence point and endpoint. Distinguish between. So, The difference between equivalence point and endpoint, isa sa pagkakaiba nila is nilang dalawa ay ang titrant ng equivalent point ng chemically equivalent to your analyte. Kung saan matatapos yung reaction, doon mo ilalagay yung point, and di rin always basihan ang pag-change ng color na may reaction na nagaganap sa mixture. Unlike sa endpoint, like if indicator changes the color, yun yung endpoint na yun. Then, kabaliktaran siya sa equivalence kasi kahit di pa tapos ang reaction, may chance na mabigay siya ng endpoint along the process of mixture. So, sa distinguish between direct titrant and back titrant is ang direct titrant titration titration is a basic titration method that involves the reaction between the unknown compound and the compound with known concentration. It says na doing this method will only give one chemical reaction, kay ang isa kay known man. At mangyayari lang ang method na ito sa paggamit ng isang known compound at isang unknown compound. Basically, if madali kunin ang endpoint, ito ang method na usually ginagamit. Pero sa back titration is iba. Titration method used to determine the concentration of unknown using an excess amount of compound with known concentration. So, si back titration is iba. Instead sa one of chemical reaction sa kanya kay dalawa. Because it needed two known compound para magawa ang method na to. Iba it says, it says excess amount of compound with known concentration. So it means madami. So more than one talagang gagamitin, unlike sa direct, kay back is malalaman mo exact point niya, may matalim or kalit na siya nag-change of color. So sa distinguish between primary standards and secondary standard is ang primary standard solution kay ito siya na solution kay made of primary standard substance. Kaning primary substance, mauni siya ang reagent na gamit kay pure o kadalasan ginagamit to create chemical reaction sa laing substance. Sa sobra ka pure niya is about 99.9 iyang purity. Less or not reactive ni siya. O ginagamit ning primary standard solution to standardized secondary reagent, and other reagent, while secondary standard solution ay solution siya na specifically for certain analysis, calibration of control materials, at maliliit na lab analysis para sa mga unknown concentration. And most sa mga substance, ani is against sa primary standard substance, which is ang secondary is not entirely pure and comparatively more reactive siya kaysa primary standard solution. Main purpose aning secondary standard solution, Jod, is for external quality of control for smaller labs to analyze specific experiment. So next, for the conclusion.
Ikaw na lang siguro, Kyle. Wala man gud si Abigail. Or
Sige. Basahin ko na lang tong conclusion niya. Conclusion, the laboratory activity 11 enable us to fill the table based on the results of the experiment. Through the wait lang. Wait lang. Wait lang. Through the obtained data, we have computed the normality and morality. Mamarinig ka! Of NH, NaHOCO3. We have determined that the purpose of orange in the experiment, wherein it is the indicator that it's being added upon the solution, which serve as a proof and gives a visible change that the endpoint was reached. Aside from that, we have also distinguished the difference between the equivalence point and the endpoint, the direct titrant and the back titration, and the primary standard and the secondary standard. Yun lang po. Thank you.
That's it. That's the end of the slides ninyo.
Opo.
Okay, wait lang ha. Okay, good. Marie? Okay nimo. Nag-request ko control. Ayan. Ako mag-control sa screen ha. Sige. Habol ninyo inyong submission for this. I think nagkaroon ng confusion last time. Itong Sunday man siguro. Pero I hope mo ha. Okay lang mag-resubmit mo sa inyong answers. So, again, this one is activity number 11, that this is acid-base titration class. So, sa activity, sa procedure, as you can see, our sample there is sodium bicarbonate. I just forgot kasi na when we did the experiment, we used a tablet. So, tablet ang amuang gigamit. Dili siya pure na sodium bicarb. Pag tablet kasi class, meron siyang sodium bicarb and meron pa siyang ibang ingredients. So that is why we cannot use the 0.35 and the 0.36 grams na given sa experiment. Okay, to siya? That is not solely for the sodium bicarb. Mo na nga sa computation, we need to look first for the amount of sodium bicarb na gigamit. Wait lang. Let us have the computation. So, mo ni inyong results. So, kanikla, sa weight per tablet, dili na to siya gamiton during the computation sa normality and even sa molarity. Na-mention na nako ang reason nga, no ha? And then the volumes, these are results of the experiment. The normality na inyong this is for sulfuric acid. This is given in the situation, in the problem. So 0.02. And then this is what you have computed. So let's check once again. Actually, nag-compute ko kagaina while you are reporting. So tama niya siya inyong gibuhat. The first step here is to compute for the amount of the sulfuric acid na nagamit during the titration. Remember, sulfuric acid is our standard solution there. Mo to siya ato ang titrant. Gi-add siya sa Erlenmeyer flask via the burette. And gitawag na to siya standard solution kasi known iyahang concentration. Remember, gihatag na ko ang concentration and it's 0.02 normal. Given iyahang volume, given iyang normality, but what we are looking first is the amount in grams of the sulfuric acid. That is why we need this formula, class. Normality is equal to weight divided by the volume times milliequivalent weight. So for sulfuric acid, this one is the computation for the milliequivalent weight. The molecular weight of our sulfuric acid is, yes, 98 grams per mole. While BF, this is also correct too. Kasi, di ba, remember, sulfuric acid is an acid, and for acid, the F is the number of replaceable hydrogen. So naay duha ka buok nga hydrogen si sulfuric acid, that is why 2. So 98 divided by 2 times 1,000 is 0.049. So mao na ato ang gamiton karon. If we derive this formula, it will become weight equals normality times volume times milliequivalent weight. So 0.02 times 70.7 times 0.049. We can get the amount of sulfuric acid na nagamit during titration. And then step number 2, you have to compute for the amount naman ni sodium bicarb that reacted with our sulfuric acid. And that's the time you have to use our stoichiometry pattern. In using the stoichiometry pattern, you also need to have the balanced equation. That is why this is also correct here that you have written the balanced equation. We have sodium bicarb plus sulfuric acid. This is just neutralization or double displacement. That is why sodium will have sulfate na. So we have here sodium sulfate plus we have hydrogen here will partner now with the bicarb. So it's okay kung giinganin ninyo siya sulat para mas dali makitaan kung balance na ba ang equation or dili. Pero actually if tarungon natong sulat ato ang chemical formula, this should be H2CO3. But okay lang ito. Okay lang. So, kung i-balance nato na siya, yes, we have here the balanced equation. 2 moles of sodium bicarb kasi we have 2 moles of sodium here. And then, 2 moles of carbonic acid. We call this carbonic acid also. Kasi why do you need 2 here? Kasi we placed 2 here, naging dalawa si bicarbonate ion. So magiging 2 din siya dito. And automatic, 2 na din si sulfuric acid. So si hydrogen, 2 na din. So this one is, again, balanced equation. And our stoichiometry pattern, you have here the grams of sulfuric acid. We'll be looking for the grams of the sodium bicarb. So our pattern is we have to convert first the grams of sulfuric acid to moles. That is why we need its molecular weight. And then from the moles of the sulfuric acid, we have to look for the moles of sodium bicarb. And to get that, we need the mole ratio. And according to our balanced equation, 1 mole of sulfuric acid is equal to 2 moles of sodium bicarb. And then since moles ang makuha nato din here, we have to convert it further to grams. And to do that, we need the molecular weight also of our sodium bicarb. And this is correct, 84 grams. So all in all, the sodium bicarb that reacted with our sulfuric acid is 0.118776 grams. So muna siya to ang gamiton karon to compute for the normality of our sodium bicarb. So asa gikan ang 20 ml, remember na sa procedure, when we pulverize the tablet, gibutang nato siya sa Erlenmeyer flask and we added 20 ml of distilled water. So dira gikan si 20 ml. So the same formula sa first part, kasi mao man gyud ang formula ni normality. So weight is kani na compute nato 0.118776 divided by 20 ml. And what is this 0.084? This is the milliequivalent weight of our sodium bicarb. And to get that, remember this formula. molecular weight of sodium bicarb is 84. And then divide it sa F times 100. Now, nganong 1 man ang iyahang F? Sodium bicarb is, ang pH niya ani basic, pero this time, we don't really consider it as base since we cannot see OH there sa iyahang chemical formula. So, ang atuang himuon, sodium bicarb will be considered as salt. And ang iyahang F is dependent on the total number of positive or negative charge niya. So sodium class is +1 and HCO3 is one entity. It's a polyatomic ion. So the charge is -1 also. So both sila 1. Kaya ang F for sodium bicarb here is also 1. So this becomes now 84 divided by 1,000. Thus, we use MEQ weight. It's 0.084 grams per MEQ. So kung atuan na ni siyang isolve, yes, this is correct also, 0.07 normal. That is the concentration for our first sample. Pero actually, the same. The same ni siya for the second tablet or for the second sample class. Balikan ako na si molarity later. Though as you can see class, na ay difference when it comes to the volume of the sulfuric acid during titration. At 67.9 ml, nagkaroon na siya o nag-change sa color, meaning nag-endpoint na. Pero when we compute the normality, 0.0679, it's a slight difference. It's slightly different from the first one, pero when we round it off, we still get 0.07 normal. The same process of computing this. Now, for the molarity, always go back with our original formula. Molarity times F equals normality. So since normality is given, pabaliktad tayo class. We have here 1 because sodium bicarb man eh. Always remember F is still 1. So i-divide lang natin na siya equivalent per mole, cancel the equivalent, ang maiwan kay per liter o per mole. Per man sila. So pag-divide nato, we will get the reciprocal. Mahimo na siya moles per liter. So the answer is still the same, 0.07. But this time, ang iyahang unit na kay molar. Okay? Questions about the computation na confused lang mo sa first part. Natingala ko, I think Saturday nag-check ko sa Schoology. Akong gitanaw ang submission. Wa pa may nag-submit sa activity number 11. So, I think na nalisdan lang, no? Pero nahimuan man siya og paraan. I hope ang mga wala pa nag-submit, ihabol ninyo to ha, kay para dili pod mo masiruhan sa inyong activity number 11. Wala mo nag-submit, 0 yun na siya automatic. Wala questions? Kaya? So, i-summarize na to ha. The first step is to compute for the amount in grams of our titrant. In this case, that's sulfuric acid. Tapos, ang second step is to compute for the amount of the sample using our stoichiometry pattern. And lastly is to compute for the normality of the sample. For the guide questions, we have here methyl orange. Yes, this is correct. Our methyl orange is the acid-base indicator. Indicator siya. So it will give us the change in color when equal amount of the sample and the titrant has already reacted. Kasi supposedly, equivalence point man dapat to siya, but equivalence point is just a theoretical point. We cannot see it. We cannot observe it using our eyes. So we use indicator. Kasi ang atong mga indicator class, when there is a change in pH, there will also be change in color. So that will signify now the endpoint for the titration. Okay, and then we have to differentiate the following: equivalence point and endpoint. Na-mention na nako, equivalence point is our theoretical point wherein the amount of the sample is chemically equivalent na to the amount of our titrant, but we cannot observe it. ang ato ang ma-observe class ang endpoint, because sa endpoint there will be a change in color of the solution, and that is due to the indicator. Kasi acid base man ito, so kung for example si methyl orange, that's our indicator, gibutang nato siya sa sodium bicarb. Sodium bicarb is basic, so that is why the original color of the solution is yellow. That's the color of methyl orange sa basic environment. Now, when we added the sulfuric acid, so definitely there will be reaction between the two, and after some time there will be a change in the pH also. So mo na siya nga at the end, from yellow it become faint pink. That's the color also of methyl orange sa acidic na environment. Mahimo na siya acidic after some time because of the addition of the sulfuric acid. So I hope na ma-distinguish na ninyo ang difference between an endpoint and the equivalent point. And then second, we have here direct titration and back titration. So direct titration, to siya itong gihimo sa sa procedure for this experiment. Now we only have one titrant. We added it using a burette sa sample placed in an Erlenmeyer flask. And then through the process, we have determined the concentration of our sodium bicarb. Ang back titration naman is another process. We do it if we cannot get a sharp endpoint. Example, the two substances don't really react rapidly, meaning slow ilahang reaction. Kapila na ta nagtuyok-tuyok class, swirl-swirl sa atong Erlenmeyer flask, wala gihapon sila nag-react. That's the time we do back titration. So how do we do the back titration? We have the sample, tapos mag-add ta og excess amount of the first titrant. Example, sodium bicarb, mag-add ta og sulfuric acid directly into the sample. After that, i-titrate nato siya with another titrant na naman. Meaning sa back titration, duha ka buok ato ang titrant. That is class the difference between the direct and the back titration. Okay? Next, primary standard and secondary standard. Primary standard is mostly solid. It's highly pure, that's 99.9%. And ginagamit natin siya for titration to determine the concentration of a sample. Pag mayon kag secondary standard, they are still considered pure. But this time it's a liquid substance. Ginagamit gahapon to determine the concentration of our sample. So reference material gihapon siya. Ang difference lang nila mostly, solid si primary standard, it's very pure, and si secondary standard liquid, naka-solution siya. Okay? Wala na ilahang difference, and wala kaayoy established na purity standard for secondary standard. Pero mostly, ang pinakadaghan nato sa laboratory class, secondary standard. Kasi gamay lang atong substance nga pure, nga very pure like the primary standard, tapos kanang mag-react dayon with our solution. So all in all class, acid-base titration is widely used in chemistry, in analytical chemistry, to determine the concentration of our prepared solution. Especially if that solution is kanang unknown ang ihang concentration, dili nato siya ma-direct o compute using the direct method. So we do titration. Okay? So I hope you can experience titration when we have our face-to-face na laboratory class na. Actually, itong gihatag na ko ni nga activity, na-confuse ko nga nung si George o kinsa tong isa. Kinsa tong isa nag-chat sa ako. Nga, sige, nagpautala sa ako og mag-experiment ba daw? O sa to? Kanus daw mag-experiment. Naglibog ko nga sila. Kita to si Jamie to. Nakalimot ko kinsa to. Basta na kadawat kong message na nagasige sila pangutana sa kuha kanus daw ang schedule sa experiment. Naglibog ko atong ba ano man di sila nagapangutana og kanus ta mag experiment. So mo na siya gitripan na sad mo. Gitripan na sad mo nila. Actually, na-clarify lang ako at the end. Kadugayan akong sigig tubag kay George. Mas si George, si Pautan, nagkano sa tawa experiment. Siya ra po iniingon nga, gitripan din ninyo sila. So, okay. Mga permi mas scam. Okay. Wait lang. Wait lang, ha? Sige. Nag-chat si Bill. Questions about activity number 11? Wala. So let's have activity number 12.